Hello, my name is Wayne Hilborn, and I am the only person that teaches that the Osirian of Egypt is a giant microwave-emitting planar magnetron, and I am about to make a case for it, so I hope you enjoy it. This is for serious Osirian researchers, and I shall start reading from now, so I hope you enjoy my presentation. Be blessed. The Osirian as an ancient magnetron. Before we unveil the bold claim that the Egyptian Osirian was not a tomb nor a temple, but instead a gigantic magnetron-like microwave emitter, we must first understand what a magnetron actually is, both in history and in function. What is a magnetron? A World War II invention that bent physics forever. The magnetron is one of the most complicated and misunderstood devices in the history of physics. It wasn't invented to heat soup, it was born in the chaos of war. During World War II, the Allies needed a better way to detect enemy planes. British physicists Harry Boot and John Randall developed a device in 1940 that could emit short-wave microwaves powerful enough for radar. The heart of this invention was the cavity magnetron, a device so mysterious and revolutionary that when it was shipped to the United States as part of the secret Tizard mission, American physicists couldn't believe it worked. As legend has it, when the magnetron was first demonstrated in the U.S., it melted a chocolate bar in a man's pocket, and radar technicians stared at it like it was alien tech. It was as if someone had smuggled a piece of the future into the 1940s. The physics confused even top-tier minds because the magnetron generates electromagnetic waves by exploiting chaos, a high-speed dance of electrons trapped in a magnetic storm inside a vacuum tube. It's not neat physics like gravity or Newton's laws. It's a storm, an art, a whisper of chaos. They try and steer electrons around a maze without it ever landing. And that's how a circular magnetron works. So imagine a donut-shaped racetrack. In the center of the track is a small tower, like the cathode, that shoots out electrons. And around the track is a metal ring with these echo chamber cavities. Now that this track has invisible imagine that there's magnetic winds blowing sideways. So when the electrons are shot out from the center, they don't just cross the track and go away. They're like bent, so they follow the track around because they're caught up in the tornado. They get bent into curves, spinning around like a roller coaster. Each time they whisk past one of the metal cavities, they push and pull on the walls with their positive and negative static electricity, making microwaves, tiny ripples of invisible energy. The result, an invisible wave of heat and power, like what cooks food in your microwave oven today. That's the magnetron. There's a magnetron in the microwave in your kitchen, but don't go digging for it. There's parts in it that are fatal if inhaled. But planar magnetrons are a flat version of the same device. Not circular like microwave magnetron, but rectangular or square like a game board. This is the planar magnetron. It's used in industrial coding, space propulsion, and advanced electronics. Here the cathode isn't a rod in the middle, it's a flat plane and electrons fly above it like bees, swarming a glowing honeycomb. Imagine a game of Pong, but in 3 dimensions. So electrons bounce, spiral, and slide across the magnetic field, kept alive by a careful balance of pressure and field strength. If you tweak the rules just right, they don't crash. They surf the field forever, spraying out microwaves of ironing gases, hitting your Pong back and forth, Pong, 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 and you're keeping the electron alive. The goal is to keep the electrons moving, trapped in a magnetic maze that teases them into producing energy. It's almost a cosmic juggling act, too much for magnetism, and if they get stuck, too little and escape. Too little magnetism and escape. They can surf EM waves if the machine is designed well enough, and that's the point of being a good magnetron designer. So the Osirian looks like it's a 5-story magnetron. Here's a planar magnetron, and you can see all the cells around the outside. And if you look at the lower cells, you can see that there's a big gap between the walls. And that's the difference that you see between buildings. Buildings usually have thin walls and big rooms, but the planar magnetrons seem to have small cells and big walls. So this here that I've been talking about and what's on the screen is actually the Osirian. This is the top view of the Osirian. Now if I put the top view of the Osirian next to what I googled to be just a planar magnetron diagram. I didn't make this diagram. I googled this, type in planar magnetron in Google in images, and you can find this exact same image. I'm just using it to show that somebody somewhere has designed a planar magnetron that pretty much emulates the Osirian at Abydos. So here is the Osirian, and it looks like it's a 5-story stone magnetron. So picture the Osirian in Egypt as seen from above, a deep buried structure with 18 visible cells, or 19, arranged like the cavities of a planar magnetron, except instead of being made of metal, these chambers are built from different types of stone: granite, sandstone, quartzite, materials known for piezoelectric, wire, and dielectric insulating properties. Suppose this megalithic device used controlled water levels to generate vacuum pressure. Lowering the water might create the vacuum necessary for a magnetron-like reaction. If the interior island functioned as a cathode, the outer 18 chambers could act as resonant cavities, each capturing, shaping, or recycling microwave bursts from circulating electrons. In this model, electrons would spiral around the center island, guided by natural magnetic fields, or perhaps magnetite-rich rocks surfing the vacuum like cosmic insects in a hive made of stone. And thus the Osirian may not have been a tomb at all, but an ancient stone magnetron, misunderstood, buried by time, and waiting us for to remember how to turn it back on. So magnetrons, they're the pulse of microwave power. A magnetron is a vacuum tube that uses electric and magnetic fields to generate microwaves. These microwaves are used in radar, particle accelerators, and microwave oven. A typical magnetron has a central cathode that emits electrons, is surrounded by a metal anode with resonant cavities, contains a vacuum, allowing electrons to spiral under a magnetic field, produces coherent microwave energy as electrons interact with cavity structures. The Osirian has a central chamber island, like a cathode, surrounding megalithic chambers, potentially acting like resonant cavities, a buried roof environment with 2 megalithic roofs, and it's buried 15 feet, which could form a semi-sealed system, perfect for creating controlled vacuum conditions. Stone blocks of varying types, possibly with differing dielectric and conductive properties, arranged with architectural intent. So now, stone as wired. Could stone be wired? You can easily Google and watch YouTube videos where people drill granite, or you can go to your barbecue and you can press the little hammer that lights the gas, and that's a hammer that strikes on a quartz crystal, creating piezoelectricity. So there's certain rocks like granite with feldspar quartz or dolomite that have piezoelectric, pyroelectric, or even semiconductive properties. So could ancient builders have chosen these stones for their electric field response, not just their aesthetics? That's something to think about. So you could think of each chamber in the Osirian as a resonant cavity, like a guitar string. When plucked, energized, each cavity can support a specific standing wave. If electron flow is passed, however minimum, spirals through a partial vacuum, the chambers could reinforce certain frequencies, amplifying a wave output. I will demonstrate how this works in a Klystron video generator video that from Creative Commons that I'm putting on in the end. It's an educational video that is excellent for teaching this sort of thing and how it works. And if you're studying this, you need to wrap your head around the inner workings of how they make electrons dance in a storm. So now, the island inside the Osirian, although it looks like it just has like a little moat going around it, that moat is actually 5 stories deep. It goes down 14 meters. And a lot of people don't consider that, but the people that are standing on the island in the middle of the Osirian, this part, if they're standing here, then they see, or they're on top of a 5-story building. Like they're on a 5-story building that's surrounded by water that's 5 stories deep. Well, we don't know, but as far as I know, it's just a straight 5-story building they're standing on top. So when you lower the water pressure in a sealed environment like that, you can scientifically create enough vacuum to make this work as a magnetron. And we see that and also creating a vacuum with water. In modern trains, air brakes fail to brake when there's a vacuum because pressure imbalances a force vector. Likewise, by lowering water level inside a sealed chamber, the Osirian could generate a partial vacuum zones, especially if we had controlled sealing through the dual roof design and being buried. Imagine lowering water from a sealed stone bathtub. The suction effect at the top is not just hydrostatic, it can literally create a vacuum pocket enough to alter electron pressure or flow. Now, I think that the Egyptians may have screwed up and left this microwave running unattended. Maybe it was intended to create an artificial water cycle where it was aimed at a lake or river, and it turned the microwaves into clouds, which turned it into rain, which gave them abundant crops and things like that. But if left unattended, this Osirian is placed right on the edge of the Sahara Desert and it's aimed west. So if this thing was just aimed west and it left unattended, then maybe the Osirian is the result of maybe the Osirian created the Sahara Desert. Once a fertile paradise, meaning being scorched not by a climate shift, but by a runaway magnetron system. Overdrive its microwave resonance until rain stopped and soil cooked. How's that for an ancient conspiracy theory? This echoes our real-world HAARP, High Frequency Active Auroral Research Program, HAARP, which manipulates ionospheric currents using radio frequencies. Could the Osirian be HAARP 1.0, buried to shield the surrounding population from space radiation? So, rocks as conductors, weighing the pros and cons. What are the pros and cons of using rocks as conductors? And I suggest all ancient fences and all the weird fence designs and around corner rocks and all that was all designed to earthquake-proof these ancient wired machine computer things because they were doing everything that we do with wires, but with machines. Michael Tellinger I don't want to say anything, but Michael Tellinger, he goes on about stuff in ancient magnetrons, and I think it's possible. And don't get me started on Göbekli Tepe, because I think the same sort of thing was going on there. So the pros of rocks as conductors. The first pro is that they wouldn't overheat as much as metal. With metal, you'd have to worry about cooling and stuff like that. So the next pro would be, piezoelectric stones like quartz generate voltage under pressure. Basalt granite can carry current under sufficient voltage gradients. Layered stone like limestone or granite may act as dielectric capacitive systems like a primitive transistor or capacitor stack. Limestone or granite. Cons: much less efficient than metals, clearly. Significant resistance and heat loss. Require far greater voltage to spark conduction. So if the Osirian used massive water current induction, it could employ moving ionic fields, electrolyze water between granite beds instead of wire-based conduction. Like the electric eel, it generates potential through layered organic material, not copper wire. Now the Klystron vs magnetron. The demonstration video that I'm going to give is for the Klystron tube, because that shows how electrons can travel in bunches.
The first cavity resonator is supplied with the weak high-frequency signal which is to be amplified. This signal will initiate an electromagnetic field inside the cavity. Due to this field, the velocities of the electrons passing through the first resonator are modulated. On arriving at the second resonator, the electrons will induce there another electromagnetic field of the same frequency. This field is so strong that it is possible to extract a large signal from the second cavity.
And how it gets sped up and slowed down by the dance of the reversing polarities of each cell based on the input of some other frequency, of the external frequency. But we'll talk about that after, or you'll see the video also, which is an excellent video. It's an open source Creative Commons video because it's sold. A Klystron uses velocity modulated electrons in a resonant chamber to produce precise microwave frequencies, like whispering into an echo cave and getting back a laser beam of sound. It's the way it takes a normal beam of electrons and it can separate it into bunches of intensity and absence by speeding up and slowing down the various parts through magnetism. So the Osirian with multiple chambers may be more Klystronic than magnetronic, resonating microwaves at controlled frequencies through dielectric stone chambers, possibly even phased like radar pulses. Could the different mineral content have created harmonic interference patterns? Think of monks humming in synchrony to collapse to make an avalanche in the snow. Physics can meet resonance. Now, could it affect the Sahara, like my ancient conspiracy theory that they left their microwave turned on and it created a desert? Could it affect the Sahara? Maybe. Localized microwave radiation can influence water vapor. Continuous microwave exposure could dehydrate soil, baking it over centuries from a giant magnetron. The Osirian is the Nile Valley, historically lush but suspiciously close to one of Earth's largest deserts. If the Osirian was activated periodically as a kind of artificial climate control, it may have helped initiate desertification if mused or forgotten. The desert was created by this Osirian machine, is my belief and theory. I'm the only person that teaches the Osirian is a giant planar magnetron. If you Google the Osirian and magnetron, my name would probably be the only one that pops up at the moment until this idea hopefully catches on, because this is how it worked, I'm pretty sure. And I would have to see a lot of evidence to make it. It would have to be. It's in related lines. If it's not exactly, my only questions are what they were used for at the moment, and I'm prepared to dig deeper. Just I have other things that I seek to know. So now, some people claim that crop circles are made with microwave bursts, causing water and plant stems to explode. And the Osirian layout, if viewed from above, resembles planar circuit architecture, like a microwave circuit board embedded in stone. It just does. It just looks like a magnetron. I've shown you. Here it is again. This is what the magnetron, planar magnetron looks like, and this is what the Osirian looks like. And I didn't draw either of these drawings. I just put them here because I want to show that I don't have any bias in the construction of these two pictures. So, just for educational purposes, I just want you to see that they look a lot similar. And if the Egyptians were using blocks as opposed to wiring, then this would make sense. So We must reimagine not only what ancient architecture meant, but what it did. If rocks can emulate wires and water can induce vacuum, then the Osirian may not be a religious monument, but a technological relic, an ancient electromagnetic monument built to pulse, hum, and resonate with a purpose now lost. Is it functional? That remains to be tested, but is it feasible on this? I argue yes. The Osirian is the buried magnetron of the ancients. I have other ancient tech videos if this one was of interest. I'm Wayne Hilborn. Be blessed. My next video is on pyramids and the Serapeum. And that'll probably be it for Egypt. Be blessed.
To generate and to amplify radio waves with very high frequencies, so-called microwaves, special tubes are required. For example, the Klystron. Consider a simple Klystron amplifier. The essentials of this simple Klystron are the electron beam, and two metal boxes known as cavity resonators. The cavity resonators have a potential which is positive with respect to the cathode. Thus, the electrons emitted by the cathode are accelerated towards the first resonator. Because the resonators have apertures in the form of grids, the electrons will continue until they reach the collector, which is at the same potential as the resonators. Therefore, in the region between the first resonator and the collector, the electrons would have a constant speed if it were not for the influence of the cavity resonators. In reality, the first cavity resonator is supplied with the weak high-frequency signal which is to be amplified. This signal will initiate an electromagnetic field inside the cavity. Due to this field, the velocities of the electrons passing through the first resonator are modulated. On arriving at the second resonator, the electrons will induce there another electromagnetic field of the same frequency. This field is so strong that it is possible to extract a large signal from the second cavity. To understand this amplification process, it is necessary to study the behavior of a cavity resonator in detail. There is a certain similarity between a cavity resonator and a conventional resonant circuit. A simple resonant circuit consists of a capacitor and an inductive loop. It is known that a conductor contains free electrons. Charging the capacitor to obtain a voltage of this polarity means that many electrons are removed from the upper plate and an equal number of electrons are introduced into the lower plate. Thus, there are two charged layers. One layer has an excess of electrons and is therefore negatively charged. The other layer has a shortage of electrons, which reveals itself as a positive charge. The electric field lines are directed away from the positive charge. If the capacitor is charged with the reverse polarity, the direction of the field lines is also reversed. The displacement of electrons in the loop constitutes an alternating electron current, which is symbolized by the variations of the green arrow. The alternating current gives rise to an alternating magnetic field. The magnetic field of the loop is out of phase with the electric field of the capacitor. At the moment that the magnetic field is at maximum strength, the electric field is zero. A quarter of a cycle later, when the electric field is at maximum strength, the magnetic field is zero. There are two similar situations in one cycle at which the fields have the reverse direction. Thus, the oscillation which was started by loading the capacitor represents a certain amount of energy that is continuously exchanged between the electric field and the magnetic field. The smaller the value of the capacitor and the inductivity of the loop, the higher the frequency of the oscillation, or the resonant frequency. With this simple circuit, a rather high frequency can be obtained, because the inductance of a single loop is very small. To obtain higher frequencies still, the inductance can be further reduced by placing two or more loops in parallel. This results finally in the formation of a closed resonator having certain very high resonant frequencies, which are determined by the dimensions and shape of the cavity. In a closed resonator, the magnetic field, as well as the electric field, is confined to the interior of the cavity. The associated currents and charges are to be found in a thin layer of the interior surface of the resonator. The first resonator of the klystron is excited by the external signal which is to be amplified. This signal, often introduced via a coaxial cable, must have a frequency at which the cavity can resonate. The current in the coaxial cable sets up a magnetic field, which in turn brings the resonator into operation. That is to say, that also an electric field is originated. It is sufficient to consider only the electric field in order to understand the modulation of the electron beam entering this first cavity resonator. The electric field lines indicate the direction of the force acting on a positive charge. The electrons, being negatively charged particles, will therefore be accelerated if they move against the direction of the electric field. On the other hand, the electrons will be decelerated if they move in the same direction as the electric field. With the alternating electric field present, the electrons will thus be alternately accelerated and decelerated. Consequently, they will enter the field-free space between the two resonators at varying speeds. In this space, known as the drift space, the fast electrons will overtake the slow ones and bunches will be formed. The second resonator is located in the position where the bunches contain the greatest number of electrons. The bunches arrive at the second resonator at intervals corresponding to the frequency with which the first resonator oscillates. As both cavities are made identical, these intervals also correspond to a resonant frequency of the second cavity. Therefore, the latter starts to oscillate. The alternating magnetic field inside the second cavity is partly linked with the coaxial cable and thus initiates the output signal. Summing up the whole action of the klystron, the electrons coming from the cathode enter the first resonator with high kinetic energy. This first resonator is set into oscillation by the input signal so that the beam is modulated and bunches are formed in the drift space. These bunches, in turn, set up an electromagnetic field of the same frequency in the second resonator. From this field we can extract a larger output signal. We must now consider why the output signal is larger than the input signal. A constant stream of electrons enters the first resonator so that almost equal numbers will be accelerated and decelerated. Thus, the average kinetic energy of the outgoing electrons is nearly equal to the energy of the incoming electrons, and almost no energy is taken from the field of the cavity. At the second resonator, however, the majority of the electrons are in bunches, and these are decelerated. Only very few electrons are accelerated. The result is that almost all the kinetic energy is converted into electromagnetic energy, the electromagnetic energy of the field which produces the output signals. Amplification of such a two-cavity klystron is too low, then multi-cavity klystrons may be used. With a very small signal applied to the first cavity, the bunches arriving at the second cavity are very weak. but they will set up a field there which is strong enough to produce more concentrated bunches at the third cavity, and so on, enabling very large amplification factors to be obtained.
And that's a wrap, folks. I hope I broadened your horizons today. As a modern Canadian magician, I've got a knack for tuning into the universe and understanding the intricacies of reality. From healing to life coaching and fitness instruction, I'm your go-to guy for a holistic approach to well-being. If today's topic struck a chord with you, send some positive vibes out in the universe. And while I don't ask for personal donations, your generosity could help elevate the quality of my future content and publications. Whether through Patreon, direct support, or local collaborations, your contributions are greatly appreciated. Remember, folks, it's all about that water deficit. Dry fasting holds the key to shedding those pesky pounds, and I'm here to debunk the myth that exercise is the be-all and end-all for our weight loss. Forget about calorie counting. It's all about tapping into that 7% water in our fat cells and saying goodbye to them forever. And let's not forget the other nugget of wisdom I bring to the table. The nature of memory is a series of simultaneous events. No brain required to store those precious moments, folks. You'll be conscious forever. If you're hungry for more of what I have to offer, don't forget to hit that like button and subscribe for future updates. Wishing blessings upon you all, and remember, in a universe governed by the mind, worry is the only true evil. Stay positive, stay blessed, and keep spreading the love.